Hello everybody. Uh, Today we will presenting about the radioactive logs. First of all, I introduce our group and Danbajit Kızgençay Ahmet and Shalabay Firnar, and Fogi second year students. Supervisor Ablay Nadir. It's our log Petroleance. And the next slide about the content is consists the introduction and the main part conclusion. First of all, I want to say about the well logging. What is the well logging? Uh, well logging, also known as borehole logging, is the practice of making a detailed record, a well log of geological formation penetrated by a borehole. The log may be based either on visual inspection or samples brought to the surface is geological logs, or on physical measurements made by instruments lowered into the hole. Geophysical logs. Some types of geophysical well logs can be done during any phase of, of a well history. Drilling, completing, producing, or bending. In addition, I want to say about the well logging is performed in the borehole drilled for the oil and the gas, groundwater, and the mineral and the geothermal exploration, as well as part of environmental and the geotechnical studies. And the radioactive well logging. Um, well logging is a technique for obtaining geological information about subsurface rocks by obtaining rock samples from the well and or by using a remote sensing device. Cores and the well cuttings uh, are actual samples of the subsurface rock materials. Devices have been developed that can test the rocks of the well hole for their electrical properties, acoustic properties, radioactive properties, hydrocarbon contents, and others. For example, well tests known as spontaneous potential tests are conducted on the rocks also of a well hole by detecting a small amount of natural electrical current that exists in the rocks. Continuous and the anions, especially sodium and the chlorine in salt water, can set up a very weak electrical current that flows through pore fluids. Petroleum is a very good insulator in respect to the current flow. Salt water and the petroleum as a pore fluid in the sedimentary rocks can be distinguished using the presence or absence of spontaneous electrical current. Uh, the next slide about the gamma ray logs. Gamma ray logs reflect natural occurring radiation in rocks penetrated by a borehole. Also, several types of rays are emitted. Only gamma rays have enough penetration to be of practical, practical use in logging the natural radioactivity of rocks. All natural rocks uh, contain some radioactive material. However, compared to the uranium or radium or even of fellow grade, the radioactivity of most rocks is very small. The radioactivity of a rock is usually expressed in term equivalent amount of radium per gram of rock required to produce the same gamma ray intensity. Also, there is no fixed rule regarding the amount of radioactivity a given rock may have because of potassium decay. Shales, clays, and marls are generally several times more radioactive and than clean sands, sandstone, limestone, and dolomites. For example, in this picture, you can see blue and black lines indicate the measure gamma rays. Sand section of interest is located at bottom of log, where the log moves to the left. Um, effect of casing. Most of gamma rays emitted by the formation can penetrate casing, so that a gamma ray curve can be obtained in the case hole. Also, the amplitudes of the curve are somewhat reduced. For example, 5/16 inch thickness of steel reduces the gamma ray intensity about 1/4. The About the effect of mud. The mud has two effects on the gamma rays curve. First, it absorbs a small percent of the radiation and therefore uh, reduces the log amplitude unless the hole diameter is very large, more than 24. This effect is very small and can be ignored. Second effect is the shale or clay contained in the mud increase the radioactivity background, so that even clean sands show a slight radioactivity on the log. If the mud is uniform, this small increase is constant from top to bottom. However, if the shale has settled at the bottom of the hole, there will be an increase in the radioactivity measured in this interval that has to be considered when interpreting the log. The effect of the mud on the gamma ray log is the same whether the mud is fresh or salty, because this effect is usually very small. A gamma ray log is very useful in wells containing salty mud, uh, since in this case the electric log is generally poor. Application of gamma ray logs. Gamma ray logs are used in the following intents. First, the to lock cased holes. No electric log can be obtained in cased holes. Second is to lock dry holes. No electric lock can be obtained in holes that do not contain water or mud. Third is to lock holes containing salt water or salty mud. The electrical locks obtained in such holes are generally poor. Fourth, the supplement the information given by the electrical log, identification of formation, estimating the amount of clay and incense, and other. Fifth, uh, about the two located radioactive ores, uranium in particular. Six, to have located lignite and coal beds. 7. To hold located clay and freshwater sands. And the next slide about the neutron logs. Neutron logs is record the response of formation to neutron bombardment induced artificially. A neutron source is lowered into the well hole. Porous units absorbs more neutrons and return or reflect fewer neutrons. Denser rock units reflected more neutrons and yield higher neutron radiation values. Porous sandstone usually have low neutron values. You can see it in this picture when the bombardment. Um, bulk density logs. Bulk density logs, sometimes called density log or density log, record induced radiation from a well hole a skidded mounted device lowered into the well hole emits medium energy electrons and measure returning gamma ray values. Gamma ray are generated by electron collisions with atoms within the rock formation. The gamma ray return values are related to rock density, and the most log density values on the log graphs are recorded as gamma divided centimeter cube. The average density for rocks of the crust is approximately 2.5 gram over the centimeter cube. You can see in this picture. Well, consolidated shales such as most Paleozoic shales have a bulk density of around 2.3 gram over centimeter cube, while consolidated sands have bulk densities are usually higher than average crustal density if well cemented and lower than average crustal bulk density if less well cemented and more porous. More consolidated Paleozoic limestone have a higher bulk densities than average crust, so it may be possible to distinguish sandstone shales and limestone from well holes, especially when well cutting accompanying well logs. And you, you can see about the bulk density of formula as a try weight divide the PR quadrant multiplied height. And as a conclusion, um, advantage about the radioactive logs. Gamma radiation is used in the treatment of the cancer and the testing equipment. It's useful and helpful for hospital. Principal isotypes emitting radiation are potassium, uranium, and deuterium. Next advantage is the isotopes concentrated in clays and thus higher radioactivity in shales than other formations, and the sensitive detector count or the number of gamma rays per units of time. The next advantage is ionization is useful for smoke detectors. It's our the advantage the radioactivity logs. And the next slide is about the reference we will use and the help for presentation. And thank you for your